guys, welcome back. So today we are going to be solving quadratic inequalities by using test intervals. Before we do, let's go ahead reminisce to like back in the day, when things were nice and pink. Okay, so in a previous unit, many moons ago, we were solving linear inequalities in a single form. So say x plus 2 is greater than 3. We work our magic. That gives us x is greater than 1. And then we are asked to write our answer in interval notation. So it will be the set of all real numbers from 1 to infinity, where 1 is excluded. Cool. So now we are going to take it ¿cómo se dice? A step up, a notch up, whatever. Okay, we're going to make it spicier. Cool. Okay, so we were solving degree 1 inequalities, hence the linear inequalities. What are we going to do now? So right now we are going to be solving degree 2 inequalities. If you want to impress your friends, you tell them we're going to solve quadratic inequality. So a quadratic inequality is the special name given to an inequality of degree 2. Fantastic. There are different ways to solve quadratic inequalities. We are going to focus our energy on solving them by using test intervals. So we have a couple of steps, well more than 2, but I'm going to go ahead and read them to you as we do our first problem. We're going to do a handful of problems, but I think what I'm going to start doing from this point forward, if the problem takes a while, I'll just dedicate one problem per video. Okay, so yeah, so let's do this. So the directions read, use test intervals to solve the quadratic inequality, and then write the solution set in interval notation. Okay, so bear in mind that we are not given the green light to solve this bad boy however we like. We have to solve by using test intervals. So it's test intervals or bust. So now, how do we solve? So the first thing I'm going to ask myself is this. Well, I'm being told that I have a quadratic inequality, but who knows, what if there's a typo? So I'm like, okay, there's an inequality symbol, hence the inequality problem. So then I'm like, what's the degree? Is it 1 or 2? The biggest exponent is 2. So I'm like, okay, we got a quadratic inequality. All right, how are we going to solve it? We're not going to solve it however we like. We're going to solve it by using test intervals. So what is the first step? The first step is to fix it so there's a 0 on one side of the inequality symbol. So I don't really care where the 0 stands, left or right, just like set it equal to 0%. Okay, so to do that, we're going to go ahead and move that negative 2x by adding it to both sides. And when we do that, will leave us x squared plus 2x minus 8 is less than 0. Okay, so goal 1 complete. Okay, goal number 2 is to find the zeros. So I want to know what makes the quadratic a 0. Okay, so if you want to know what makes the quadratic a 0, you're going to go ahead set it equal to 0. Before we do that, let me go ahead factor completely. I hope it's factorable. Okay, so a prerequisite step when it comes to factoring is to watch out for common factors. But x squared, 2x, and negative 8 don't have any factors in common other than 1, so we're good. Depending on the type of polynomial that you have, that will determine the strategy that you will use to factor. Trinomial. If I have a trinomial, I'm always going to cross my fingers, literally, and ask myself, is the leading coefficient 1? And in this case, it sure is. Okay, so because the leading coefficient is 1, we don't have to use the AC method unless you really want to. So let's do this. We're going to go ahead, throw down parentheses, focus on getting the product of the first terms. Last time I checked, the product of the first terms, to get it, we're going to use variable times itself. To complete the binomial factors, we want factors of c that add up to b. So we want factors of negative 8 that add up to 2. Someone asked me, do we have to bust out an x game? The answer is no, but if you need it, go for it. Okay, so factors of negative 8 that add up to 2, I think there's a 4 and 2. And in this case, where the larger factor should be positive. So let's go ahead and check it. Product of 4 and negative 2 is negative 8. Sum of 4 and negative 2 is 2. Cool. And again, for old time's sake, if you want the x game, then go for it. So we check it. Product is negative 8. Sum is 2. We're good. So let's go ahead bring down the rest of the problem. Okay. How do we solve a quadratic inequality? So it's a 4-step process. 1, fix it so there's a 0 on one side, and then 2, find the zeros. So if you want to know what makes it a 0, then you're going to take the inequality and the equivalent of set equal to 0. I think I'm a little redundant. Okay, so let me go ahead, take our inequality in factored form and set it equal to 0. Okay, so now at this point we have a product that equals 0. So from back in the day, if a product equals 0, when we apply the zero factor property, if a product equals 0, then there's no way around it. One of those factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. Okay, if the first factor equals 0 after we subtract 4 from both sides, that will give us x equals -4. Okay, so someone said, oh, you skipped a step. Skipping one step is okay, but skipping more than one makes me nervous. Okay, if the second factor equals 0 after we add 2 to both sides, that's going to give us x equals 2. I'm going to go ahead and highlight this. Okay, why? Because that was one of our steps. I'm not going to box it, because if I box it, the grader is going to think that's our answer. Okay, so step number 1, fix it so there's a 0 on one side. 2, step number 2, find the 0, so what makes it a 0? Cool. Step number 3, we're going to use the zeros we found to split the number line into test intervals. Okay, in short, find the test intervals. Okay, so in English, let's go ahead, locate the zeros to split the number line into test intervals. The zeros are -4 and 2. This is a number line, so values to the left are smaller, values to the right are larger. So we have -4 and then +2. Okay, we locate them. But now the question is, are these zeros part of the solution? Well, that is dictated by the inequality symbol. Because the inequality symbol doesn't have the equal to part, we're going to go ahead and use an open circle. So let me put a little love note. Okay, so we use open circle. Why? Because of the inequality symbol. So let's go ahead and put open circle at -4, open circle at 2. Someone said, can we use parentheses? You know what? Go for it. If that works for you, that's fine. But whenever I graph something on the real number line, for me, the open and closed circle notation is good. Okay, so to recap, how do we solve a quadratic inequality? So step number 1, sorry if you see me pause, because I pretty much broke down step 2 into 2 parts. So step number 1, fix it so there's a 0 on one side, and then 2, find the zeros. Step number 3, identify the test intervals. So pretty much we're going to use the zeros to split the number line into test intervals. Test interval number 1, I would really appreciate it if you go ahead, label it as such. It's going to be the intervals from -infinity to -4. In English, it's going to be the numbers less than -4. Test interval number 2 is going to be the numbers from -4 to 2, and then test interval number 3 is going to be the interval from 2 to infinity. In English, the numbers that are bigger than 2. Okay, so once you find the zeros, go ahead, use those zeros to split the number line into test intervals. When we have 2 zeros, it looks like we're going to have a total of 3 test intervals. What are we going to do now? We're going to test out each interval to see which one of these is a solution. Okay, so again, I need you to label them. Okay, so we're going to go ahead, show our work, test interval number 1, and then you're going to pick a test value. What's test value? A test value is a value that you're going to test out to see if it's a solution. Since we're testing the first interval, we want to test out any value that's under -4 or that's in this interval. It doesn't really matter what you test out. For me, yes, we could use a calculator, but I'm going to try to freehand it as much as possible. So with your permission, we're going to test out -5. -5 is in this interval, so we're good. If you're like, no, I'm going to test -67, go for it. Okay, do what you got to do. Okay, so we cannot read each other's minds, so our test values may not necessarily be the same, but that's fine because the interpretation or the outcome should be. Okay, so I want to know, is our test value, whatever you chose in that first interval, is it a solution? Now, the book says and the world says you should test it against the original inequality. It doesn't really matter. Okay, with your permission, I'm going to test it into the one that's being compared to 0. Why? Because it's easier for me to compare to 0 versus compare to -2x. So let me go ahead, write down that inequality. So we have x plus 4 times x minus 2 is less than 0. And in moment of truth, we want to know if our test value is a solution. So let's go ahead and show our work. So we have negative 5 plus 4 times x, which is negative 5 minus 2. And I want to know, is that less than 0? Let me go ahead, zoom in. Sum of negative 5 and 4 is negative 1. Difference of negative 5 and 2 is negative 7. Product of negative 1 and negative 7 is 7. And the question of the hour is 7 less than 0? I know that you know that 7 is not less than 0, so it doesn't check out. You could put false, but the word false and true doesn't really resonate with me. If it checks out, I'll put a check mark. And if it doesn't check out, I'm like, it doesn't check out. But you do what you gotta do. So the moral of the story is this: because negative 5, or our test value, is not a solution, that means that no other value in that interval is going to be a solution. So with your permission, I'm going to cross it out. Do you have to cross it out? No, but I like to. Okay, so one interval down, 2 more to go. So remember, each interval must be tested. So where should we show work? I'll do it right here. I think I can fit it. Okay, so please go ahead, label what interval you're testing. That'll be the only way that I'll be able to follow. Okay, so test interval number 2, you can test out any number between negative 4 and 2, and of course the endpoints are excluded. You can use decimals for all I care, but I'm going to go ahead, just use integer values. Is 0 in here? It sure is. So whenever possible, I'm going to test out 0. You're like, no, I'm going to challenge myself. I'm going to test out 1.99. You know what? You're already challenging enough, so don't make this as more difficult than need be. Okay, I'm going to go ahead and use that same inequality. So let's do this. So we have x, in this case it's 0, or any number in that interval, plus 4 times x, which is 0, or whatever you chose, minus 2. And I want to know, is this really less than 0? Sum of 0 and 4 is 4. Difference of 0 and 2 is negative 2. Product of 4 and negative 2, where am I, is negative 8. And the question of the hour is negative 8 less than 0? Last time I checked, negative 8 is less than 0. So what's going on? Because 0 is a solution, that means that every single real number in this interval is also a solution. So let me go ahead, graph them. Someone said, do we really have to graph our solution? The answer is no. We're just asked to solve it and write the answer in interval notation. The reason why I graph my solution along the way is because the worst thing that I can do to myself is do all the algebra, but then fail to answer correctly, okay, just because we couldn't see the big picture. All right, 2 intervals down, 1 more to go. Okay, so test interval number 3. So we're going to pick any value that's, I guess, pretty much bigger than 2. So with your permission, we're testing out the number 3. Okay, and in this case, let's see what we get. We're going to use that same inequality. So we have x, which is, in this case, 3 plus 4. We multiply it by x, which is 3 minus 2, and again, or whatever test value you're picking. And I want to know, is this less than 0? So let's do this. Sum of 3 and 4 is 7. Difference of 3 and 2 is 1. And the question that we're going to ask ourselves is this: is 7 less than 0? I'm like, no, we already said it wasn't. So the point of the story is this: since our test value, in this case 3, is not a solution, that means that no other number in this interval is going to be a solution. So let's cross it out for dramatic effect. So what is the answer? Okay, the solution set is given by the set of all real numbers from negative 4 to 2, where both endpoints are excluded. Okay, so it's the interval from negative 4 to 2. My mistake. Okay guys, so just to recap, how do we solve quadratic inequalities? Okay, if we solve by test interval, because that's what the directions say, step 1, fix it so there's a 0 on one side. Step 2, find the zeros. step 3, use these zeros to split the number line into test intervals. Please identify them 1, 2, 3, because if you don't, it's going to make it that much difficult to follow your work. Step whatever is next, test each interval. Put the interval number, put your test value, and then plug it in. It will be nice if I can see at least once what inequality you're using. Okay, and if you don't, then I hope to be able to follow your work. Okay, but if you write it once, then you don't have to write it up again. Okay, do show your work and then interpret it. Is it a solution? Is it not a solution? Okay guys, that's my time. Come back for the next problem. Thanks.